Assalamu alaikum students. Today we are going to discuss about the properties of ionic compound. As we have discussed about the ions, ionic compounds, their formation and how you can write the chemical formula of ionic compound. Today we are going to discuss about the properties of ionic compound. After this lecture, you will be able to describe how ionic compounds form giant ionic lattices, able to explain why ionic compounds have high melting and a boiling point, and you will be able to explain why ionic compounds cannot conduct electricity when solid, but can conduct electricity when they are in a molten form or when they are dissolved in a water. Here you can see the structure of sodium chloride, ionic structure of sodium chloride. Sodium having atomic number 11, chlorine having atomic number 17. Sodium having 1 electron in its outermost shell and chlorine having 7 electrons in its outermost shell. So sodium as highly electropositive, it will donate its electron to the chlorine, and chlorine due to highly electronegative element, it will take the electron from sodium and become negative ion, and sodium by donating electron becomes positive ion. Positive ion is also called as cation and negative ion is also called as anion. So by the donation of one electron from sodium, its new electronic configuration is 2,8. And by taking one electron from the sodium, chlorine having no electronic configuration, that is 288. K shell having 2 electrons, L shell having 8 electrons, and M shell having 8 electrons. So you can see here both having their octet completes. That's why they are stable ionic compounds. Next, here you can see sodium chloride, the common salt that you use in your house. This is the complete atomic ionic structure of ionic compound sodium chloride. Due to the electrostatic forces of attraction between these ions, the ionic compounds, the many particles of these ionic compounds are attached with each other. Here you can see the giant structure. Many of the positive and the negative ions, here you can see the sodium ion, chloride ion, again sodium ion, then chloride, and you can see. So in this manner, many of the positive and the negative charges attach to each other due to the strong electrostatic forces of attraction between them because of the charge formation. Due to these electronegative forces between these ions, they are closer to each other and making a giant structure. Next, here you can see giant lattice structure of ionic compound. In ionic compound, opposite ions are attached with each other and attracting the opposite ions. Sodium ion having a positive charge, chloride ion having a negative charge. So these positive and a negative charges attract each other and making a giant ionic lattice. Here you can see the three-dimensional structure of lattice structure of ionic compound. In three sides, positive and the negative ion attach with each other and make a very strong bonding, with each other due to the high electrostatic forces between these two ions, and they are tightly packed together. Here by this arrow shown the electrostatic forces. This is ball and stick structure. With the balls, ions are shown, positive and negative ions, and with the sticks, bonding forces, electrostatic forces are shown. So these electrostatic forces between these ions combining the opposite charges together and making a very strong structure and very packed structure. Closely this look like this structure. No bonding is shown. All the balls are come closer due to the highly electrostatic forces between them. So in the last you see this type of lattice structure between ionic compound. Opposite charges are combining together. In this lattice structure, the green balls are for sodium and red balls are for chloride ion, and these positive and the negative ions, when they regularly arranged in a three-dimensional structure, they make a strong lattice structure. This structure is very tightly packed, and this structure you can see here in the form of ions, in the forms of atoms. Each ion is attracted to all those around it. Each ion is attracted by all the atoms around it. For this lattice structure, you can see here the ball and stick diagram. Ionic compounds having a very high melting and boiling point. Previously, you have seen the lattice structure, that is very tightly packed structure of ions. So keep that structure in your mind and try to understand this. Ionic compounds having very high melting and a boiling point, which means you need a very high energy to break their electrostatic forces. They having a very strong electrostatic forces. These electrostatic forces keeping the opposite ions together. So that's why you need a very high heat energy to break these electrostatic forces. When you are providing heat to the lattice structure, then those ions which are regularly arranged, tightly packed, start moving away from each other, start moving randomly. Due to that random motion, of the ions, by providing heat, they will separate out. They will lose their electrostatic forces. To weaken their electrostatic forces, you need a very high temperature. That's why ionic compounds having a high melting and boiling point. Stronger the electrostatic force, higher will be the melting and a boiling point. Those having a single ions attached to them having a less melting and a boiling point, and those having a more than one opposite ions are attached to them having a high melting and a boiling point because of high electrostatic force between them. Ionic compounds conduct electricity when they cannot conduct electricity when they are solid. Ionic compounds do not conduct. For example, you are taking common salt and trying to conduct electricity from it, then it will not conduct electricity. Ionic compounds in a solid form do not conduct electricity because their opposite ions are tightly packed together. There is no spaces between them for the movement of the ions, for the movement of the electrons. So that's why they do not conduct electricity, because there is no space for the ions to move. They are tightly packed together in a three-dimensional lattice structure. They are tightly locked in their places because of the strong electrostatic forces of attraction between them. Ionic compounds can conduct electricity when they are melted or dissolved in water. When you dissolve the ionic compound, when you dissolve, for example, common salt, sodium chloride in a water, you can conduct electricity because by the melting or by the dissolving of water molecule, by the dissolving of ionic compounds in water, they will separate out into their ions. Sodium chloride will divide into its ions. So when the ions are freely moving in a water, they conduct electricity through it. And when you are melting the ionic compound, then their ions are start moving. They will lose their strong electrostatic forces, weaken their strong electrostatic forces, and randomly start moving. That's why they conduct electricity. When ionic compounds are solids, they do not conduct electricity, but when they are dissolved in a water, they separate out in their ions, they loosen their intermolecular forces, they loosen their electrostatic forces and start moving. Next, here you can see melting point and a conductivity, the overall view of melting point, boiling point of ionic compounds and the conductivity of the ionic compounds. As I told you, like lattice having a strong intermolecular forces. Ions in a lattice are tightly packed together. They having a electrostatic forces that these forces are holding these ions. When you are providing heat to the ionic compound, more heat to the ionic compound, these ions will be random in a random motion, lose their bond, and that's why ionic compounds having high melting and a boiling point. Conductivity, their conductivity is based on ions. If they are moving in a form of ion in a solution or in a molten state, then they conduct electricity. When they are in a strong lattice structure, they do not conduct um, electricity because there is no space for the movement of the ions. They are very packed, very close together. So if you want to conduct electricity from the ionic compound, you have to dissolve it into a water or melt it. Then it will be easier to conduct the electricity from ionic compound. Ionic compounds are soluble in water. When they soluble in water, then they conduct electricity.